Hi everyone and welcome back to another lab. In today's lab, we are going to show you how to configure and verify static NAT in a small lab topology that demonstrates the use case for using static network address translation. So static NAT is used when a one-to-one mapping between a private IP address and a public IP address is required. This is often necessary for servers or devices inside a private network that need to be accessible from the outside network, such as web or FTP servers. So as usual, we will briefly explain what is NAT and why we need it and how it works. Then we will go through the lab topology and the lab objectives, and then I'm going to cover the lab tasks and finally walk you through the lab solution. So by the end of this lab, you will be able to understand what static NAT is and when to use it. You will also be able to configure static NAT on a Cisco router to translate a private IP address to a public IP address and verify the static NAT configurations using ping and HTTPS protocols, for example. So NAT stands for Network Address Translation, and it is a process used in networking to modify IP address information in packet headers as they pass through a router or a firewall. Network address translation plays a crucial role in connecting private networks to the internet. So NAT is commonly implemented on routers that connect internal networks to the internet, serving as an intermediary between private IP addresses which are not routable on the internet and globally unique public IP addresses. So the primary way NAT works is by translating private IP addresses to a public IP address as traffic leaves the internal network and directing the response back to the correct internal device. When a device inside a private network sends a packet to an external network, the NAT-enabled router replaces the private IP address in the packet's header with the router's public IP address. It also keeps track of the connection using a table that records the private IP address and the translated public IP address. When the external network sends a response back, the router uses this translation table to direct the packet to the correct internal device by mapping the response back to the original private IP address. So basically, NAT is essential for several reasons. Firstly, it addresses the problem of IPv4 address exhaustion by allowing many devices to share a single public IP address. This is particularly important because there are far fewer IPv4 addresses available than there are devices that need internet access. Secondly, NAT provides a layer of security for internal networks by hiding the internal IP addresses from the public internet. This makes it harder for external attackers to directly access devices within a private network. Finally, NAT enables efficient routing of traffic by allowing private IP address spaces to be reused within different networks. That ensures internal network structures can remain unchanged even if the public IP address changes. Okay, so regarding the lab topology, as you can see on the screen, we have router 1, which will act as the border router for the LAN network of 10.0.0.0/24. Router 1 is connected to switch 1 via gig ethernet 0/0/1, which in turn is connected to a couple of hosts. Specifically, switch 1 is connected to PC 1 via fast ethernet 0.1 and is connected to IEE server via fast ethernet 0.2. Router 1 is also connected to the ISP router, allowing traffic to flow to the internet. And the public IP address assigned to router 1 will be 203.0.113.1. And we are going to statically map the IEE server to 203.0.113.3, and we will do the same for PC1 with this public IP address, which is 203.0.113.4. And the main objectives of this lab is to allow internet host PC to access the IEE server via HTTPS and also to be able to access PC1 via ICMP protocol. Finally, all end devices are pre-configured with IPv4 address settings and they are good to go. Okay, so regarding the lab tasks, we will start by configuring gig ethernet 0/0/0 and 0/0/1 interfaces on router 1 with the appropriate IPv4 address settings, and we will also enable both interfaces. Next, we're going to move to step number 2, where we are going to create a default route pointing to the ISP router. And then we're going to jump into step number 3, where we are going to designate each interface with the appropriate NAT configuration. And then after that, we're going to go to step number 4, where we are going to configure a static NAT to perform some static NAT mapping. And then after that, we're going to jump into step number 5, where we're going to perform some connectivity tests and observe the NAT translation and statistics. And then we're going to go to step number 6, where we can save our configuration, and that will be the end of our lab. Okay, this is the moment where I ask you to pause the video and try this yourself to test your knowledge and skills. So I have added the lab document in the video description so you can download it and practice at your own pace. I have also included a couple of packet tracer labs for you to download. You will find a pre-lab and a post-lab version. The pre-lab is for those who want to tackle all tasks from the beginning, while the post-lab provides the full lab solution. Okay, so I'm going to tackle the first task. So I'm going to jump into router 1. And I'll go to the CLI, and from there I should be able to go to user privilege mode and then go to global config, and then I'm going to tackle interface gig ethernet 0/0/0, which is connected to the ISP router. So I'm going to set the description first, and I'm going to say link to ISP. I will set the IP address with 203.0.113.1, and that is going to be /29, which is 255.255.255.248. I would need to enable the interface, so I'm going to say no shutdown. And then what I'm going to do, I'm going to exit, and then I'm going to go to interface gig ethernet 0/0/1. I'll set the description first with link to switch 1, and then I'm going to set the IP address with 10.0.0.254. The subnet mask is going to be 255.255.255.0, and I would need to enable the interface, so I'm going to say no shutdown. Next, I'm going to perform some pre-checks. So I'm going to say show IP interface brief. And right now you can see that both interfaces that we just configured are in the up state. Each interface is configured with the appropriate IPv4 address settings. So what I'm going to do next, I'm going to jump into step number 2, where we need to configure a default static route. So I'm going to go back to global config, and I'm going to say IP route 0.0.0.0, and the subnet mask is going to be 0.0.0.0, and then the next hop address will be 203.0.113.2, and then I'm going to hit end, and then I'm going to issue the show IP route for verification. So I'm going to say show IP route, and you can see that we have configured a default static route that pointing to 203.0.113.2. Next, I'm going to jump into step number 3, where we need to designate each interface with the appropriate NAT configurations. So I'm going to start with interface gig ethernet 0/0/1. So I'm going to go to global config, and then I'm going to say interface gig ethernet 0/0/1. I will then say IP NAT, and if I question mark that, you can have the content sensitive help, and you can see that we have 2 options. And what we need to do is we need to configure this interface as an inside interface, and because this interface is pointing to the internal network, I'm going to say IP NAT inside. I'm going to hit exit, and then I'm going to jump into the next step, where we need to do the same for gig ethernet 0/0/0. So I'm going to say interface gig ethernet 0/0/0, and I'm going to do the same thing. I'm going to say IP NAT, question mark that again, and this time I'm going to configure the outside option. Then I'm going to hit end, and then after that I will do some verification. So I'm going to say show run pipe section 0/0/0 with a $sign. And as you can see, this is the current configuration under this interface. And you can see that we have configured IP NAT outside under gig ethernet 0/0/0. I'm going to up arrow this, and I'm going to change the interface ID from 0 to 1. And here you can see that we've configured this interface with the IP NAT inside. There is also another command that I would like to share with you, which is the show IP NAT statistics. So if we were to look at the output, as you can see on the screen, you can see from the first line here that the total active translation is set to 0, as we didn't configure any static map for network address translation yet, but we will do that next. And then the second and the third line indicates that the outside interface is gig ethernet 0/0/0, and the inside interface is gig Ethernet 0/0/1. And then if we were to look at the hits and misses, the hits option shows the number of successful NAT translation that have matched an existing NAT entry, whereas the misses header indicates the number of times a NAT translation was required, but there was no existing translation entry, leading to the creation of a new dynamic translation. And then if we move to the next one, which is the expired translation. This indicates the number of dynamic NATs entry that have expired and were removed from the translation table. And then finally, we can see the dynamic mappings headers. And this basically provides details about the dynamic NAT or PAT. We will discuss this in the upcoming video. So we will leave this as is for now. Okay, so what I'm going to do next, I'm going to go to step number 4, where we need to configure a static NAT. So I'll go back to global config. And I'm going to say IP NAT, and then I'm going to question mark that to reveal the content sensitive hell. And what we're going to do to perform a static mapping between a private IP address and a public IP address, we would need to say inside source. And then if we question mark that, we have the option to use static. So I'm going to use the static option. And then we would need to set the IP address that is being assigned to the IEE server. And the IP address that is assigned to that server is 10.0.0.100. So I'm going to say 10.0.0.100. And then next, we will need to set the public IP address that will be used for the translation between the private and the public IP address. So I'm going to say 203.0.113.3. And then I'm going to hit enter. And then what I'm going to do next, I'm going to do the same thing for PC1. So I'm going to up arrow this, and I'm going to change the private IP address to 10.0.0.10. And then I'm going to change the public IP address from 203.0.113.4. So now that we've done that, let's do some verification. So I'm going to hit end, and then I'm going to say show IP NAT statistics. And this time you can see from the first line here that we have configured a couple of NAT static entries, but nothing have been used so far. So what I'm going to show you next is the show IP NAT translation, and then I'm going to hit enter. And as you can see on the screen, there are no active translations as we speak, but we will do that next. But let me just explain the table that you see on the screen. So the first column, which is the pro, stands for protocol, and that indicate the protocol used for this specific NAT translation. We can also see the inside global column. This is the public IP address that is assigned to an internal device. We can also see the inside local, and this is the private IP address assigned to the internal device within the local network. And then we can see outside local, and that is related to the IP address of the external device as it appears within the local network. And then the outside global, this is the IP address of the external host as it appears in the outside world. Okay, so what we're going to do next, we're going to perform some connectivity tests. So I'm going to go back to my topology, and I'm going to go to internal host. And then I'm going to go to the desktop and then go to command prompt. And from there, I am going to issue a ping command to 203.0.113.4, and then I'm going to hit enter. Okay, so we can see that we have connectivity. We have lost the first couple of ICMP packets, but that's due to an ARP request. So if I repeat that command again, I should be able to have full reachability, as you can see on the screen. So if I go back to router 1 quickly and up arrow this, here you can see that the protocol that has been used for the network address translation is ICMP. This is the inside global, which is referring to the public IPv4 address, which is assigned to an internal device. And this represents the ICMP identifier for the response. You can see this is the IP address that is assigned to PC1. And this IP address is the public IP address that is being assigned to the internet host. And you can see the IP address matches the outside global as well. Okay, so as you can see, the first test was successful, and we have received a static translation between the private IP address that is assigned to the PC to the public IP address, which is 203.0.113.4. Now what I'm going to do, I'm going to go back to the internet host PC, and then I'm going to try to HTTPS to the IEE server. So go back there. I'm going to close this application. and then I'm going to go to the web browser. And in here, I'm going to say HTTPS colon / / 203.0.113.3. And I'm going to press go. As you can see from the screen, we have managed to reach the web page of the internal server with the public IP address of 203.0.113.3. So what I'm going to do, I'm going to go back to router 1. I will up arrow to get the same command, and I will hit enter. And here you can see that we have received 2 new translations that are active. And this time we are using the protocol TCP. You can see this is the public IP address that is assigned to the IEE server. You can see that we are using port number 443, which indicates that we are using HTTPS. The inside local is 10.0.0.100. Again, we are using port number 443. And then it's coming from 198.51.100.1 with a random port number, which is 1025. And also the outside global is 198.51.100.1 with the same port number, which is 1025. So what I'm going to do next, I'm going to issue the command show IP NAT statistics. And this time, if we look at the first line of the output, you can see that there is 2 in front of static, which means that there are 2 static NAT entries, and there is 2 dynamic, which means that there are 2 dynamic NAT entries that is being created dynamically based on traffic, and 2 extended as well, which refers to extended NAT entries, which might include port translation or special mapping. You can also see that we have 25 hits and 9 misses as well. And the expired translation were 7. And if I reissue the same command again, it looks like we have the same statistics, and the reason being is because the web page is still up and running and active on the internet host PC. So if I issue the show IP NAT translation, we still can see these 2 entries. So what I will do, I will go to internet host PC, and I'm going to stop that. And then I'm going to go back here, and I will up arrow this multiple times. Okay, so it seems that these 2 entries are not being removed. So if you want to remove these entries, what you can do, you can issue the clear IP NAT translation. And we also need to include the star, which indicates all entries. And then I'm going to hit enter. And then I'm going to issue the show IP NAT translations. And you can see that these 2 entries have been removed. And now what I can do, I can issue the show IP NAT statistics. We can see this time that we have only 2 static NATs. There is no dynamic or extended NAT translations that are active at the moment as we speak. That's it, folks, for this video. If you found this video helpful, please don't forget to give it a thumbs up. And if you haven't already, please hit that subscribe button and turn notifications so you never miss our future tutorials and tech insights. If you have any questions, comments, feel free to drop a comment below. I read all your comments and I'm here to assist you. Remember, consistency and hands-on practice are key to success. So stay curious, stay inspired, and until next time, peace.